Okay, so we are going to look at some more optimization problems now. This problem I got from the textbook. It's page 143, question number 7, and it says the diagram is this diagram here, represents the end view of the outer cover of a matchbox. So imagine a matchbox, and it might look a bit like this, and not one of the expensive matchboxes you get. One of the cheap matchboxes you get from like a bar or something. Not that I go to many bars, but that's beside the point. It says AB and EF. AB and EF have been that's a typo right there. AB and EF have been gummed together. Have been gummed together. And gummed together, that just means they've been glued together and assumed to be the same length. So although they're probably not the same length, for maths purposes, we've assumed they're the same length. If the total length of edge A, B, C, D, E, F, the total length being the whole thing, is 12 centimeters, calculate the length of AB and BC, which will give the maximum possible cross-sectional area. Okay, so I haven't actually done this problem before, so I'm doing it from scratch as well. So what I'm going to do is write down what we know, and that will hopefully help me to approach this problem. So what we know. Okay. What we know. So we know that AB equals equals EF, because we're told that in the question, and that obviously equals DC. Okay. This length equals this length equals this length. That should be quite obvious. Next length ED equals length BC, and you can see that from the diagram as well. Okay, cheers. I shouldn't even do this. Okay. Is that all we know? We know that the total length A, B, C, D, E, F, that's a mouthful, A, B, C, D, E, F equals 12, okay? At some point we're going to want some sort of formula for area, and I think what would be good is if I include a variable, and the variable I'm going to include is x there. Okay, so we can say that that is equal to x. I'm not sure what I'm going to do for the length yet. Why am I not sure about the length? I have no idea. Right. Oh, I know what to do. Okay, so we know that this length here, if we do the total is 12, well, what is the total length? If I'm gonna, I'll call this y for now, and we'll change it later. So the total length is going to be, we've got 1x there, 2x there, and 3x there, and then we're going to have this y and this y. So it's going to be, the total length is going to be 3x plus 2y, and we know that's equal to 12. Okay, so we can get an expression for y in terms of x. So we can say that, you know, this is using basic algebra, 2y equals 12 minus 3x. Okay? So y is therefore equal to 6 minus 3 over 2x. That's good, that will help us. Okay. We want to minimize, or sorry, we want to maximize the cross-sectional area. So we want to maximize this area. So, what is the area? The area, I'm going to write area because I've used A before. The area equals, well, it's just x times y, isn't it? X, y. What is x, y? Well, x, y, we can change y because we really just want an expression in terms of x, because we don't want, we want as few variables as possible. So that will help us differentiate later. So we can get rid of this y, because we know that y is equal to 6 minus 3 over 2x. So that means that the area is equal to x times 6 minus 3 over 2x. Okay? Cool. I'm going to expand this bracket because we need to differentiate it. Okay? That's 6x minus 3 over 2 x squared. Lovely. So we are wanting to maximize this area. So that suggests that we want to find stationary points. Stationary points, or a stationary point. Because this is a quadratic, there are probably going to be, there's only going to be one stationary point. Okay, so we're going to differentiate the area with respect to x. So that's going to be d area dx. Okay, be careful with your notation. Okay, so when I differentiate that, when I differentiate the area, I'm going to get the 6 from this term here, and that's going to be minus 3x. Okay. And because we want stationary points, we want this gradient function to be equal to 0, because we know that is going to give us stationary points. So when we set that equal to 0, we can solve for x. So that means that 6 equals 3x by adding x to both sides, which means that x equals 2. Okay? So x equals 2 will maximize our surface area, or our area. It will also satisfy our initial condition, and our initial condition was that the total length would be 12. Okay. Good. Is that all of the question answered? So if the total length of the edge A is 12 centimeters, calculate the length of AB and BC. So we haven't calculated the length. We have calculated the length of AB because we know that's 2. So now all that's left is to calculate the length of BC. So what is the length of BC? Well, BC is equal to y, and y is equal to 6 minus 3 over 2x. Okay. So 6 minus 3 over 2x. So that's 6 minus 3 over 2 times by 2. That's 6 minus 3, so that's just going to be 3. And just for clarity, let's imagine putting this back into our A, B, C, D, E, F. So we know that A, B, C, D, E, F equals 3x plus 2y. 3 lots of x plus 2y, because that's the length of this matchbox. And 3x, well, that's 6, plus 2 times 3 plus 6, well, that's going to be 12. As it should be, because that was our constraint to start with. Okay. Do I need to show this is minimum or maximum? Well, not really, because we know that there's only one stationary point, because it's a quadratic. And this quadratic, if I plot it, it's going to look something, it's going to cross the x-axis at 0. It's going to cross at the origin. It's going to have a minimum at 2, and at 2, the minimum of the area is going to be 4 times 3 over 2. So that's minus 6, and then 6 times 2 is 12. 12 minus 6, so it's going to have a minimum at 12 minus 6, that's 6. Is that right? 2? Yeah, I guess it is. Yeah, it's going to have a minimum at 2, 12. Ah, no, sorry, my bad. It's actually, it's going to have a maximum at 2, 6. So that's going to be 2, and that is 6 there. Okay, and this is an unhappy quadratic. Okay, sad face. Looks like that. Okay. There is only one stationary point on a quadratic, and in this case it must be a maximum. Okay, I guess that's question solved. Done.